Alright, this is our last test that we're going to go over for the midterm for CP Geometry, so let's get started. I've got the picture right here a little bit bigger, a little clearer, so you can see a little bit better, but we're going to answer these questions. This is point U is the incenter. Let me just talk about that for just a second. The incenter, okay, is a point where we're going to have an angle bisector in all these angles, okay? So if I bisect angle G, bisect angle Y, bisect angle H, they all meet at this point right here. Now notice, this isn't just a straight line that goes all the way through like this, okay? So don't get confused on that, even though sometimes, like this one, it kind of looks like MY is like a nice straight line, but it's not necessarily a nice straight line. The angle bisector comes to this point. I bisected this angle, comes to this point. Bisected this angle, comes to this point. So what's true about this point right here? Well, this point from U to all three sides of the triangle are the same measurements. So from U to M is exactly the same as it is from U to P as it is from U to B. So all three of these, we'll even mark it if you want, all three of those segments right there are equal to each other. And we also know that these angles are being bisected. So that should help us out. That's all true about an incenter. All right. So let's go through and figure out what the measurements of these values are, what these measurements are. So MU, so from M to U. Now look, remember, all three of these little segments right there are equal to each other. Well, they tell us this one is 3, so I said all three are the same. So if this is 3, then guess what MU is? It's going to be 3 as well, because all three of these are the same distance from the incenter to this point, to this point, to this point are all exactly the same. They tell us 1, that means this is 3, and if they asked you, they don't on this problem, on this test, but if they asked you what UB was, that would be 3 as well. Let's go to number 2. UGM, angle UGM. So let's find that. Here's U, here's G, here's M. We got to find this angle right there. Remember the first thing I said about the incenter. The incenter is found by bisecting all three angles. So this whole angle right here, this big angle HGY, or this big angle G right here, is being bisected, which means it's being split into two equal parts. So if this part right here is 32, then guess what this is? Well, that's 32 as well. So angle UGM, let's write that down, UGM is also 32 degrees. So far so good. We didn't even have to do any math at all. All you had to do was recognize what was true about the angles and about the lengths of these little segments right there. So let's go to number 3. It says PHU. Here's PHU, so this angle right up here is what we're looking for. Look, same idea as this one here. Remember, the angles are being bisected, so if this is 33 degrees, guess what this angle right here is? That's also 33 degrees. So angle PHU is 33 degrees. Look, we didn't have to do any work at all. Didn't even have to do any math. All you had to do is recognize. You have to know something, though. It's not like you didn't have to know anything. You had to know about the incenter, right? And you had to know the relationship between the sides and the angles on the incenter. All right, let's move to the next one. Okay, this one right here, 4 and 5, is the circumcenter. Right here's the word, circumcenter. We have to know something about the circumcenter. The circumcenter is found by taking each of the three sides and finding the perpendicular bisector of the three sides. What does that mean? That means we take this side, we find the bisector of that side, which means T is the midpoint. And we draw a line so it's perpendicular to that midpoint. We do the same thing with AB. R is the midpoint, so we draw a perpendicular line at that midpoint. AC, we take the midpoint of that, which is S, and we draw perpendicular from that. Now watch what it does. It goes to here, goes to here, goes to here. I didn't extend them all the way through, but they will meet at this point P right here. That's called the circumcenter. Now, what's true about the circumcenter? By the way, remember, these are midpoints, so that side and this are equal to each other. This and this are equal. Let's make it actually hit the line. Those two are equal, and these two right here are equal. Why are they equal? Because T, R, and S are all midpoints of those sides. Now look at point P. The distance from B to P, A to P, and C to P, the distance to the from the vertices to this point, this circumcenter, they're all equal to each other. So BP, tell you what, I'll just make like a thicker. Instead of doing 4, since I got 1, 2, and 3 here, let's just make this a little thicker. Alright, so from the vertex to the circumcenter, vertex to circumcenter, vertex to the point, they're all equal to each other as well. Okay, with that in mind, let's go to this. It says SC is 5. So watch, SC is 5. and BP is 7. BP, so that right there is 7. All right, let's see what they ask for. Number 4, they ask for AS. So find AS. AS is right here. Well, that's pretty easy. Look, that's got 3 tick marks. That's got 3 tick marks. Remember, this is a midpoint. So if this is 5, then what's AS? That's going to be 5 as well. So AS is equal to 5. Simple as that. Let's look at number 5, which is AP. Find AP. That would be this one right here. Now remember, they told you BP, right, was 7. So remember, the length from each vertex to that point, to that circumcenter, is exactly the same. So from BP is the same to CP as it is to AP. So if this is 7, guess what AP is? That's 7 as well. So AP is also 7. That was pretty simple. Again, boy, we haven't done any math at all. All we've done is just looked at this stuff, but you have to recognize things, okay? You got to know what's equal to what. If you didn't know what's equal to what because of the circumcenter, you wouldn't be able to get this right. But it is kind of easy because you can just kind of see which ones are equal. Let's go to 6, 7, and 8. All right, let's take a look at the next picture. It says triangle CDE, use the centroid. So what in the world is the centroid, that point right there? Well, you find the centroid by finding the median of the triangle, of all 3 angles. What is the median? What is the median? It's all E's. Okay, what is the median? It's from the vertex to the midpoint of the opposite side. So it goes from the vertex to the midpoint of the opposite side. So M is a midpoint. Watch, from D to J. J is a midpoint. From C to K. K is a midpoint. So let's mark it. So CM and MD are equal to each other. CJ and JE are equal to each other. And then EK and KD, or DK, whatever you want to call it, they're equal to each other. So that's kind of nice. And this is that deal where it's the 2/3, 1/3 thing. Remember that? So from the vertex to the point, that line right there, see that? UD? Compared to JU or UJ. UD right here is twice as big as UJ is. So this segment from the vertex to the point is twice as big as the segment from the point to the midpoint. All right, from the centroid to the midpoint. So this is twice as big as this. Same thing here, watch. CU is twice as big as UK. EU is twice as big as UM. Let's take a look at the whole thing. If this is twice as big and this is only half as big, okay, if this is twice and this is 1, that's 3 altogether, so EU would be 2/3 of the whole entire thing. UM would be 1/3 of the whole entire thing. So I don't want to confuse you anymore. Let's just put some numbers in and see how it works out. So UK is 15, so let's mark that. UK is 15. We'll put a 15 right here. And it says EM. EM, that might be a mess if I try to put that in here, but I'll just write it up here. EM is 24. Okay, so from E all the way down to here is 24. If I tried to put this in here, I got so much junk all around, it'd get a little confusing. And UD is 12. So UD right there is 12. All right, let's see what we can do here. Number 6. It says find CU. CU. Now remember, CU is twice as big as UK. So if UK is 15, CU is twice as big as this. So what do we do? Just 2 times 15. 2 times 15 is 30. So CU is 30. All right? Number 7. MU. Let's find MU. Now here, this is where we're going to use that EM. See, watch. EM is that whole entire thing. Now if you know the whole entire thing, the easiest thing, I think, anyway, to find is the shorter part, which is right here. That's what we're trying to find anyway. That's MU. So if I know the whole thing, what is it? It's not half of the whole thing. Remember, this is half of EU. It's not half of the whole thing. What is it? It's 1/3 of the whole thing. If I know the whole entire thing, EM, which I know is 24, UM, or MU, is 1/3 of the whole entire line segment. So how do I do 1/3? Well, it's just dividing by 3. So 24 divided by 3 is 8. So MU is 8. I'll write it right here. MU is 8. All right, let's take a look at number 8. Number 8 is JD. I'll write it. I should have done it for number 7. But anyway, JD, let's find that. JD, we want to find the whole thing from here all the way to there. Well, they kind of tell you part of it, don't they? They tell you UD is 12. Now remember, from the vertex okay, from the corner of the angle, that's a vertex, to this point right here in the middle, that's twice as big as the shorter part right here. So if this is twice as big as this, then this has got to be 6. But that's not my answer. They don't ask you for JU or UJ. They're asking you for JD, from here all the way to here. So if this is 6 and this is 12, what's the whole entire thing? 6 plus 12 is 18, and that's JD. Okay, let's look at this one. It says list the angles in order from smallest to largest. Here's the picture up here. Well, you can see which sides are smaller. Okay, that's the smallest side, that's the next one, that's the biggest one. We want to find the angles. Remember the rule. The rule says you look at the angle opposite the sides. If this is my smallest side, you look opposite, which is angle Q. That's the smallest angle because it's opposite the smallest side. So angle Q is the smallest one. The next one would be side 5, okay, but look opposite. Look at the angle opposite 5. That would be angle R. So that would be the next biggest one. So angle R. And then 7 is the largest side out of all 3 of them. So look at opposite side 7 and look at angle P. Angle P is opposite the biggest side, so angle P is the biggest angle. So that's the smallest, that's the middle one, and angle P is the largest angle. You just look to see opposite those sides, and there you go. All right, let's take a look at this one. This one says, number 10, list the sides in order from the smallest to the largest. Problem is, don't know this angle right here. So how am I going to know which side is bigger and which one's smaller? I can't just go by looking at the picture. I can't always tell by that. But I'm going to have to figure out what this angle is. Well, you should be able to figure that out. All right, if you take 180, well, let's do this first. Let's add these up. 105 and 31. Okay, that's 136. So these two add up to 136. Take it away from 180, and that would be 44 degrees. So that's what this angle is right here. That's 44 degrees. So that's the first thing you need to be able to do. You got to find what that angle is. All right. Now you got to find the sides in order. See, find the sides in order from the smallest to the largest. So what do we look for first? We look for the smallest angle. Here's the smallest angle, and you look at the side that's opposite the smallest angle. That's the smallest angle. Watch. You go across from it. UT is the smallest side. So UT is the smallest side. What's the next smallest, or the next biggest angle? That would be 44. So look at the side across from 44, which would be right here, TS. TS is opposite 44, so TS is the next biggest side. And now, look for the biggest angle. The biggest angle is 105. Look across, look opposite that 105, and it's US. And US is the biggest side. That's the smallest side because it's opposite the smallest angle. That's the middle side because it's opposite the middle angle. This one right here, US, is the biggest side because it's opposite the biggest angle. And you need to have it in that order. Okay, number 11 says find VU. So here's your situation. You've got this triangle, you've got these two equal sides, and you're trying to find VU. Well, it's pretty straightforward, I think. Look, these two are exactly the same. They're equal to each other because of the tick marks right here, and you're trying to find one of the lengths of the sides. So first of all, you got to find what x is equal to. If these two sides are equal to each other, so you just set those two things equal to each other. 7x plus 2 equals 3x plus 10. Let's solve for x. Subtract a 3x from both sides, that's 4x. Subtract a 2 from both sides, it's 8. Divide by 4, and x is 2. That's not my answer. The question says find VU. I got to find this whole length right here. So you're going to plug in x to that value right there for x. So it's 3 times x, which is 2, and then plus 10. That's 6 plus 10. And so VU is equal to 16. Make sure you plug it back in if it asks you to, and it does. It says find the length of VU, and so we got to find x, plug it back into this, then you work it out, and you get 16. All right, number 12, it says find angle MFZ. Let's find that, MFZ. We're trying to find this one right here. Okay, well, we have a theorem that says this. It says if you have a point, let's see, if you have a point and it's equidistant from the two sides of the angle, then it lies on the angle bisector. All right, look it up. It's on there. I forget exactly what lesson and stuff, but it's on there. If you have a point that lies equidistant, and that's the distance from here to here because it's perpendicular. This is equidistant from the two sides of the angle, then it lies on the angle bisector, which means that if it lies on the angle bisector, this angle and this angle are equal to each other. So that makes it nice. So now I can, if I want to solve for this angle, I got to find what x is. So I can find x by setting these two things equal to each other. So 2x minus 1 equals x plus 9. Subtract x from both sides, I get x. Add a 1 to both sides, I get 10. It's not my answer. I got to plug it back in. I got to find this angle. Remember, it says find angle MFZ. Make sure that you find what they're asking for. Don't just assume they only are asking you to solve for x. So it's x plus 9, which is 10 plus 9, and that's 19. So angle MFZ is equal to 19 degrees. Alright, 13 to 15 are basically the same kind of problem. Alright, so you just have to remember something. In order to form a triangle, if you have three sides, watch, I'll do number 13. If you have three sides and you need to determine if those three sides can actually make a triangle, you take the two shorter ones, okay? That would, in this case, would be 5 and 7. So you add the two shorter ones, the two smaller ones together, and if I add them together, it has to be bigger than the third side, or the largest side. So if I add the two smaller ones together, it has to be bigger than the larger side, or that third side. So 5 plus 7 is 12. 12 is greater than 8, so that works. So yes, that does make a triangle. Let's try 14. We do the same test, okay? We just have to determine if it's greater than. Sometimes they are, sometimes they're not. So let's take a look at these numbers. I got 7, I've got 13, and I've got 20. So watch what I do. I take the two shorter ones. That would be 7 and 13. I add them together. It has to be greater than 20. Well, what's 7 plus 13? Well, it's 20. Is 20 greater than 20? No, it's not. So, no. You cannot make a triangle with sides 7, 13, and 20. 15. I've got sides 15, I got 20, and I've got 40. Take the two shorter ones. In this case, it's 15 and 20. So 15 plus 20. If I add those up, they should be greater than, they should be greater than 40. Let's see if it is. Well, if I add those up, that's 35. Is 35 greater than 40? No, it's not. So no. All right. Now right here, a lot of people think it could be equal. No, these are equal to each other. It has to be greater than. It's got to be bigger. 20 is not bigger than 20. It's equal to it. It's got to be bigger. 35 is not bigger than 40. It's smaller. So no, you can't get a triangle out of that. So that's how you do those. Pretty simple. It's the same routine. And that's it. Let's do 16 and 17. All right, number 16, it says find the range for the measures of the third side of a triangle given the measures of the two sides. So this time they don't give you three sides, they only give you two. They give you 10 and they give you 25. So those are two sides of a triangle. I want to find the range, the possibility that the third side can actually be. So it can't be any length at all. It has to fit within a certain range. And how do we find that range? It's actually pretty easy. What we do is we take these two numbers right here and we subtract them. We actually got a lot of people missing this problem on this test. There's no reason for that. This is really, really simple. So watch what I do. Two things. I do two things, not just one thing. Some people are just giving me one answer. I need two different possibilities, a range from somewhere to somewhere. So what I do is I just subtract them from each other. Okay, 25 minus 10, and that's 15. And then I have to do a second thing. I add them together. 10 plus 25 is 35. That's my range. So my third side can be any side between 15 and 35. This is how I write it though. I say x could be the number, or n, or you can use any letter you want. X has to be between 15 and 35. And how do you write that? You write it just like this. Notice both arrows are pointing to the left. If you read this one from left to right, what does it say? It says x is greater than 15. So x has to be a number bigger than 15, and x has to be a number that's, look, smaller, less than 35. That's what it means. This means x is between 15 and 35. This is how you write it. Don't just write 15 and 35. Don't write 15 in an arrow to 35. Write it like this. Put an x in between, left, or you put a less than sign, subtract the number, put it on the left, add the number and put it on the right. It's as simple as that. It's a really easy problem to get right. Watch, I got 54 and 7. 54 and 7. So again, how do you find the smaller of the two numbers? You just subtract them. 54 minus 7. 54 minus 7 is 47. And then how do you find the bigger range? You add them up. 54 and 7 is 61, so you put that there. What goes in the middle? X goes in the middle, goes less than, and then you're done. That's all there is to it. Really simple. Alright, we're almost finished. This is the last little section right here. So we want to compare the given measures. When it says to compare them, it tells you, or it wants you to find out which one is bigger, which one is smaller. So take RQ and PQ. Is RQ less than PQ, or is RQ greater than PQ? That's what we have to figure out. So let's take a look. RQ. Let's actually mark RQ on our picture. We'll just put it with one little tick mark right here. And let's mark a PQ. And we'll mark it with 2 little tick marks. We got to find which one's bigger. How do you know if one's bigger than the other? Do you just look at the picture and say, "Well, that one looks like it's bigger than that"? Not a good idea. Always go by the numbers, because sometimes it's not always drawn to scale, and sometimes you just can't tell. So you got to know by the numbers. So here's a situation. This is called the side-angle side inequality theorem. We won't worry too much about that. But look, I've got 2 triangles, and look, this side is opposite 95 degrees. This side is opposite 85 degrees. So you look to see the side that's opposite the biggest angle. That's the biggest side. Or you look at the side that's opposite the smallest angle, and that's the smallest side, however you want to do it. So look, 85 is smaller, so QR, or RQ, watch, let's put it in the order that they give it to us, okay? Put RQ first and PQ second. So compare RQ to PQ. Well, RQ is smaller than PQ. Why? Because it's opposite a smaller angle than PQ is. This is opposite 85. This one over here, PQ, is opposite 95. So 85 is less than 95. So RQ is less than PQ. Same idea over here. Let's again put it in order. Angle STR and TRU. Angle TRU. And it's either going to be less than or greater than. Okay, let's not just guess and throw something in there. Let's see what's going on. Angle STR. Let's mark STR. These are kind of off kilter a little bit, but that's okay. That's angle STR. That would be this one right here. And then TRU. That would be this one right there. I'll put 2 arcs just to show they're not the same. Now look, these are angles, so I'm looking at the sides that are opposite these angles. Look at the side that's opposite this angle, STR. If you look opposite, that's 31. Look over here at angle TRU. TRU is right here. Look at the side that's opposite that. That's 30. Well look, STR is opposite 31, and TRU is opposite 30, so STR has to be, this angle STR has to be bigger than this angle TRU, because it's opposite a bigger side. See? Opposite 31, opposite 30. Bigger, smaller. Number 20. Let's mark angle R and angle T. I'm just going to write a less than or a greater than here. Let's take a look. Look at angle R right there. Look at angle T right here. Angle R is opposite 20. Angle T is opposite 21. So angle R is opposite a smaller side than angle T is opposite. And so that means angle R has to be less than angle T. That's how you write it. Okay, put it in the right order. I had a lot of people putting PQ is greater than RQ, and that would be correct. It wouldn't be wrong. I didn't mark it wrong. But I just, you know, they put it in this order, and just say less than, greater than. And that's it. That's the only 2 options. All right, so there you go. There's your test. So we've gone over every single test that we've taken this year, every single problem that could possibly be on the midterm. So be ready for it. Now, hopefully you're watching these. If you're not, then I'm just talking to no one then. All right. Well, good luck on your midterms. Hope you do well, and we'll see you in class.